In this lesson, we will discuss how to form different types of valid sampling techniques for a particular scenario. The scenario we have is we want to find out about the number of hours worked per week for the students at your local high school. The high school has a population of 3,200 students. Discuss how you would select a sample of 400 students from the population of 3,200 students for each of the sampling techniques listed below. The first sampling technique we'll discuss is the simple random sample. If we want to use simple random sampling, the first thing we should do is assign unique labels to all 3,200 students. One way to do that is to use 4-digit labels starting with 0000, 0001 all the way up to 3199. Once we've assigned unique labels to all 3,200 students, we want to use a random number table, selecting 4 digits at a time from the table, or a random number generator to get the sample. And we would have our simple random sample of size 400. If instead of a simple random sample we wanted a stratified random sample, what could our strata be? We want our strata to be alike as possible. Every individual in a particular stratum should be as alike as possible to help reduce the bias in our sample. Plus, it will guarantee representation from each of those stratum. Recall, we are in the high school setting. What if we divided our population of high school students into 9th graders, 10th graders, 11th graders, and 12th graders? Presumably, our 9th graders would all be alike, the 10th graders would be alike, the 11th graders and 12th graders. Now that we have our population divided into strata, we want to select a simple random sample from each of our stratum. We want a total sample size of 400, so we could take a simple random sample of 100 from each of our 4 stratum, and we would have our sample of size 400. What if we want to use systematic random sample? The first thing we must do in systematic random sample is determine our block size. Our block size is equal to the population size divided by the sample size, which is 3,200 divided by 400, which equals 8. Our block size is 8. The second thing we want to do, now that we know our block size is 8, we should divide the population into blocks, and each block should be of size 8. Then we should label individuals in each block from 1 to 8. Now we need to decide which individual from each block we should take to put into our sample. We need to randomly choose a number from 1 to 8 because remember there are 8 individuals in each of our blocks. We can do this using a random number table or a random number generator. Suppose the random number that was chosen was 7. Then we should select all the individuals that are labeled 7. There should be 1 from each block, so there should be a total of 400 such individuals with a label of 7. These 400 individuals make up our sample chosen using a systematic random sample. If we were doing a cluster sample for this particular problem, what would we do? We need to divide our population up into different clusters. What could we use as a cluster? What if we chose the classes that meet during 4th period on a particular day? We have our 32 high school students, and our clusters, each class meeting 4th period is a cluster. Suppose there are 100 classes that are meeting during 4th period. We have 100 clusters. If there are 100 clusters, we want to label those clusters or classes. We could label them 0, 0, 0, 1 up to 99. We then want to take a simple random sample of 13 of these classes or clusters, again using a random number table or a random number generator. Every one in the selected class or cluster would be in the sample. If we were doing two-stage sampling, we would start out identically as we did in the cluster sampling. We start with the 3,200 high school students. We divide the population of 3,200 students into clusters. We said that a cluster would be a class that is meeting during fourth period, and we had 100 clusters or 100 classes. We label the classes 0, 0 up to 99. In the cluster sampling, we took a simple random sample of 13 classes and then selected everybody in that class. Instead of taking everyone in a selected cluster, we will take a random sample of clusters and then we will do an additional random sample of individuals in that cluster. So instead of taking 13 classes or clusters, we will need more in order to get our sample size of 400. Let's say we are going to randomly select 26 classes out of our 100 clusters. And instead of selecting everyone in the cluster, we want to take a simple random sample of size 16 from each of the 26 selected clusters. And that's how we would do a two-stage sample for this particular scenario.